Set notation. The first point is, what is a set? A set is a collection of well-defined and distinct objects. It can be described by putting its components. For example, set A is 1, 2, 3, 4, 5, 6. And what are the elements? The elements of a set are the items in it. Elements can be anything. It can be numbers, characters, locations, and so on. To represent is an element of, we use this symbol. For example, if n is equal to 1, 2, 3, 4, then this 1, 2, 3, 4 are elements of the set n. What is a universal set? The universal set is a set that contains all of its subsets elements as well as its own. It is represented by capital letter U or by Greek letter Xi. What is an empty set? The set that does not contain any element is called empty set. For example, a set of natural numbers less than 1. It is expressed as empty brackets and represented by Greek letter phi. Number of elements. Number of elements in a set A is denoted by n of A. For example, if A equals AEIOU, then number of elements in a set A equals 5. Note that if B equals 5, then number of elements in a set B equals 0 because 5 represents the empty set. If C equals this set, then element of C equals 1 because here 0 is the element of set C. Examination tip. A cross through the sign indicates that it is not true. For example, this means is not equal to. This means does not belong to. This means neither a subset of nor equal to. And it means not a subset of. Next is set operations. There are three major types of set operations. The first is union of sets. Union of two sets A and B is a set which contains all the elements of set A and set B. It is represented as A union B. For example, if set A equals 1, 3, 5, 7, 9, 11 and so on, these are odd numbers, and set B equals 2, 4, 6, 8, 10 and so on, which are even numbers. Then, the union of set A and set B equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and so on. So, union of these two sets will contain all the elements of set A and set B. The next is intersection of sets. Intersection of two sets A and B is a set which contains all the common elements of set A and set B. It is represented as A intersection B. For example, if set A equals 2, 3, 5, 7, 11, 13 and so on, these are the prime numbers. And B equals 2, 4, 6, 8, 10 and so on, these are even numbers. Then intersection of A and B equals 2, because the common element of set A and set B is 2. Next is complement of a set. If U is a universal set and A is any subset of U, then the complement of A is the set of all elements of the set U apart from the elements of A. It is represented as A prime or A complement. For example, if U equals 1, 2, 3, 4, 5 and so on, which is a set of natural numbers, and A equals 2, 4, 6, 8, 10 and so on, this is a set of even numbers, then complement of A equals 1, 3, 5, 7, 9, 11 and so on, which is a set of odd numbers. So U is a set of natural numbers, A is a set of even numbers, then complement of A will be set of odd numbers. Properties of set operation. The first is commutative property. A intersection B is equal to B intersection A, or A union B equals B union A. Associative property. A intersection into B intersection C is equal to A intersection B intersection C. Similarly for union, A union into B union C is equal to A union B into union C. Distributive property. A union into B intersection C is equal to A union B intersection into A union C. Similarly for intersection, A intersection into B union C equals A intersection B union A intersection C.